Hello and welcome to this video about Nitro X7. Nitro X7 is a new steel that has been developed by Buderus, Germany, and I have been asked to look into this steel and report my findings, and I did so, and I have to say this steel is extremely interesting, and if you want to know more about it, stay tuned and watch this video as I will tell you everything I have found out about it. Since I'm a firm believer in real-world testing, I decided to make 4 identical knives in 4 different steels. The first one, of course, being Nitro X7. This is the red-handled one. Then we have M390 with the black handle, MagnaCut with the yellow one, and last but not least, Nitro V with the green handle, which is the predecessor to Nitro X7. Before I will go into the details of the knives I made, the microstructure, the hardness and the process, I would like to show you how I actually made these knives, because I think this is very interesting and it also highlights how difficult it is to make 4 exactly the same knives for comparative analysis. Now the first thing you can see here is the drilling of the tang holes. That is obviously not something very interesting, but what is interesting is the shaping, because all of these blanks not only have to be exactly the same shape, they need to be ground wet, so there's no chance of overheating the material even before heat treat. And speaking of heat treat, all of the blanks I grind oversize. This extra meat, so to speak, on the edge will be gone after the heat treatment. I will remove this very carefully to make sure all the edge areas are 100% the same. Here you can see the cryogenic treatment, which all of these knives got. And here you can see the surface grinding in order to prepare the blades for the hardness testing. The hardness testing, of course, had to be done very precisely, and I always use a hardness calibration block, which you can see here, to make sure that the values I get are accurate. The hardness block has a hardness of 63.97 Rockwell C, and you can see the calibration was perfect since we got 64.0 Rockwell, so very, very accurate. The first blank being tested here is MagnaCut, which I heat treated to 63.5 Rockwell C. Maybe you will asking why 63.5 Rockwell C, and the answer is that I found MagnaCut to perform the best at 63.5 Rockwell C. Yes, it can go higher, but when it comes to edge stability, I found that MagnaCut isn't ideal above that hardness. The next blank you see is M390 at 64.5 Rockwell, which again is in my book the ideal hardness for it. Then we have Nitro X7 at 63.3 Rockwell. And last but not least, again, we have Nitro V, which I took to 62.0 Rockwell, which again is the hardness I find to be ideal for this steel. Interesting to note already is that with the same austenitizing temperature, Nitro X7 gets over 1 Rockwell C harder than Nitro V, so that's good and convenient for everyone doing large-scale heat treatment. It has a good hardening response. The next step you can see here was extremely important, and it was the removal of the extra steel I had left on for heat treatment. By removing this in the same manner with lots of coolant on every blade, I made sure that we compare only a perfect microstructure on every blade, which is absolutely essential for getting good results. After that, I was left with 4 identical blanks and it was time to grind. Now you can see I use a lot of coolant, and I do not just dip the blade into a bucket of water in between, I use stream coolant, and this is extremely important. If I wasn't to use coolant and just dip the blade into a bucket of water or didn't use any water at all, I would be sure to overheat this blade, and we can't have that. And yes, it's somewhat controversial, but the only way to prevent overheating a blade is with flood coolant. With the blades themselves being finally done, I was able to move on to the handles, and I decided to use my micarta because it is robust and very nice to work with. The next step was shaping the handles on my belt grinder, which also I do by hand. All my knives are handmade, and if you decide to buy a knife from me, you will get a handcrafted piece that will last for generations. I make sure that all the handles are very flat, so there's no gaps between the handle and the micarta, which is so important to prevent moisture slipping in. And you can see me here how I construct the tang. I always use Corby bolts, and in this case I had to turn the Corby bolts down in order to make sure that they are perfect. Because if they are too long or too short, the handle won't be very secure. You have to make them exactly as long as needed, which you can see here. Now it was time to glue up. The blades and the handle scales were done. I didn't film that, it's not very interesting, and this is the result. The next step was finally the shaping of the handle, which is a step which I always very much enjoy. While I can do about 50% of the shaping on the belt grinder, the other 50% I need to do by hand. It's just more efficient for me. Yes, I can be faster on the belt grinder, but doing it 100% manually with sandpaper, I can be 100% assured that the knife handle fits the hand perfectly. I decided against the polish simply because these blades would be abused quite a bit, and so I moved on to sharpening. The sharpening I did at 17 degrees per side on all blades with my trusty Wicked Edge system. Now there are many sharpening systems out there, and I get many questions which one I recommend. For this case, I chose the Wicked Edge, having many systems at my disposal, because it was not only very fast, but it is the most rigid system I know of. While sharpening, I made sure that I applied the same number of strokes on all blades on every side in order to make sure that these blades are as comparable to each other as possible. The progression I used was 200, 400, 600 and 1300 on the Wicked Edge stones, and after that I went on to 3 micron lapping films. I always used plenty of lubricant, which is a special lubricant for sharpening that is based on mineral oil. You can see me apply it here. This is especially important for using the diamond lapping films, as it makes sure that there is no swarf accumulating on the films. After I was finished with the stones and the lapping films, I thoroughly cleaned everything and then moved on to 0.25 microns stropping with CBN compound. Now then, with the knife being done, I can finally show you the composition of Nitro X7, because I think that is what most of you have been waiting for. As you can see, it is very similar to AABL or Nitro V. However, we have somewhat more chromium compared to Nitro V, and we have the same amount of nitrogen. So the overall carbide formers are increased. What makes this steel so special is that it can compete in some categories with PM grade steels, and even sometimes beat them when it comes to lateral edge stability. And it basically means that the edge on this steel can withstand a lot of pressure coming from the side, which is extremely important for a steel and often underestimated as a quality when it comes to knife steels. The way I tested this is as follows. I would first do a push cut test through a piece of staple. With a defined force, a hammer being dropped from a defined height would cut the staple on a piece of wood, and the knife had somewhat allowance of sideways motion, as you can see here. Then I would move on to cutting hard jarrah wood with a defined amount of cuts. And finally I did 40 cuts in manila rope with each blade, and that concluded the cycle of testing for each blade, and I think this gives a very accurate representation of what the blade typically has to go through. Some staples, some wood, some rope. After I had the blades put to all of these steps, I put them in my Newton sharpness tester, which basically is a very interesting way to test blades. It not only tests for apex refinement and thinness like a best tester, it also tests for the behind the edge thickness, and this is something very important. But for this experiment we only focus on the apex integrity, and here you can see how it works. A thick Teflon strip is with a defined force being pushed over the blade and retracted, and the force is measured, and then you get these interesting curves. And this device would warrant its own video, and maybe I will do one day, but right now let's just focus on the results. You can see this curve, the higher the peak is, the higher the amount of force necessary to cut through the test medium, and the higher the amount of force, the duller the blade is. It really works very similarly to a best test, which you probably know about. Here you can see all the individual curves for all the steels after all the tests had been done. So these curves were done after all the cuts were made through the staple, the wood and the rope. Looking at these curves as they are right now, there is not too much to be seen. All you can see basically is that there is two peaks in the middle, and those peaks are where the staples had been cut and a chip is formed. However, if we look at an Excel charts of each of these curves, we can see a lot more. What we can see is that M390 took only half the amount of force compared to MagnaCut and Nitro X7 to cut through the test medium. So this means the chip inside the M390 blade after cutting through the staple was only half as big, more or less, compared to the MagnaCut and Nitro X7 steel blades, and it was even only a third as big compared to the Nitro V blade. Now, does that mean that M390 is the best steel and we don't need to look at anything else? No, of course not. And basically, this test says nothing about the individual steel grade, and I only show it to you to drive home a point that I have been talking about a lot. The higher the hardness of a blade is, the better it will withstand plastic deformation under pressure, and this is exactly what happened here. We had a lot of pressure on a small point, which was the staple, and the hardest steel, being M390, did the best. I only show you this because it is part of the bigger experiment, which is simulating a typical wear on the blade. But nonetheless, I think talking about this is very important because just simply cutting a staple doesn't tell you anything about how nice a steel is or isn't. Now with that out of the way, let's look at what actually made the difference and caused some of these steels to chip so badly. If we look at these images again, we can see some of these steels having huge issues and, well, I wouldn't call them issues, but let's just say problems with edge stability. And I found that what caused these huge chips is the wood cutting. When I looked at the wood cutting and after that at the rope cutting, I found that when investigating the edges along these processes that they would gradually degrade during the wood cutting and then pretty much stay the same during the rope cutting. This is the reason why I think rope cutting alone isn't a good test. The same goes for Catra. If you want to really look at edges and see what they are capable or incapable of, you need to put them through real-world testing. So this is why I did all of these 3 tests, and along these tests I did some investigations, as you can see here, and pretty soon I saw the problems with M390. M390 by far did the worst in this test, and it's not a bad steel, but it's, I think, not really suitable for hardwood cutting. I think we can say that much. And it, however, did quite well still in the abrasion resistance category. When I looked at this edge, it still had very sharp parts. MagnaCut wasn't as nice as I hoped it would be. It didn't chip like the M390, but you can see it rolled. And this is something I had seen before on MagnaCut, and this is a problem that I found to get much worse the higher you go in hardness. It's not to say that this is a bad steel, but this shouldn't be the case, I think, with any steel if you want to use it for hardwood cutting. Again, if we do rope cutting tests, this steel will not show these problems, but hardwood cutting, like we did it, really led to problems here. Nitro V did both roll and chip, and the chips and the rolls, while smaller compared to MagnaCut and M390, were more frequent. So I wouldn't say this steel is a good steel for hardwood cutting either. And that brings us to Nitro X7 and my final conclusion. As we can see, Nitro X7 took much less damage than any of the other steels. It still took damage, and I don't want to hide that fact. You can see it did chip, but the chips were very minor. And if you remember that Nitro X7 is not a PM grade steel and was put to the test to very popular PM steels like MagnaCut and M390, I think this is very, very impressive. And Nitro X7 is a steel that not only impresses me in the department of edge stability, it also takes an amazing edge. It is truly a sharpener's dream steel, and if I have the time, I plan to make a separate video about that as well. But for now, I think we can say with safety that this steel is amazing for what it is. If you watched this entire video, I thank you very much for your interest and I hope it was of value to you. And special thanks go out to Buderus Germany for providing me with the Nitro X7 steel as well as the Nitro V steel, and even more to Dr. Trinks from Buderus Germany for doing these amazing micrographs of the samples I sent to him. My name is Roman Kase from Kase Knives Switzerland, and if you have any questions to me directly, please feel free to reach out to me at contact@kase-knives.com. Thank you.